Rahim. So, dear students, there is a drill problem which apparently troubling few of our dear students. Although to me it's pretty straightforward, and there is nothing complex in it. But let's see how to proceed. So this is specifically drill 2.5, in which we have to find vector electric field intensity. Due to two infinite line charges, one is lying on entire x-axis, the other is lying on an entire y-axis, and both have got the same magnitude, which is given by 5 nanocoulombs per meter. So that's the charge distribution, and the field point in part A is given to be PA with the coordinates 0, 0, 4, and in part B the coordinates are given to be 0, 3, 4, and this will call point PB. So let's see how to solve the first problem, that is the part A. So let's look at the field point. Definitely the coordinates tells us that the field point lies on the z-axis. So for electric field intensity due to an infinite uniform line charge density, we know that we have got a formula which is rho L upon 2 pi epsilon naught rho A rho. So this is A rho, okay, this is not AY, so A rho, okay, where this rho L is given to us 2 pi epsilon naught. We already know. We only have to calculate two things, rho and A rho, and we all know that this rho is nothing but the perpendicular distance between the field point and the line charge. Okay, so basically what we would be needing electric field intensity at this point in part A will be given by electric field intensity due to should I write it like rho L x line charge density, which is lying entirely on x-axis, plus electric field intensity at this point due to the line charge which is lying on y-axis. So let me write it rho Ly. Okay, so both should be found out first in vector form and then added together to get the final answer. So let's see how to find this rho Lx. Okay, so we will use this formula. So the line charge density on x-axis has got the magnitude of 5 nanocoulombs per meter divided by 2 divided by pi divided by epsilon naught, and the value we already know. So and then now we need to know the distance, perpendicular distance between the field point. This is PA 0, 0, 4, and the line charge, and the line charge is on x-axis. So we already know that this part is very simple and straightforward. We already know that this z-axis, if I'm already on z-axis and I want to find the perpendicular on y-axis, or the perpendicular distance, this distance, so in which direction would perpendicular go? The perpendicular line will follow exactly the z-axis and will reach origin. So actually this is the distance which is required. This distance is actually rho. Okay, so the length of this distance is should I mark it in black? I hope that would be better. So there we go. I hope you would see it in black. There we go. Okay, so this is the length, and we should already know that this length is 4. I'm not writing here, right, because we have to solve the part B as well, and I want to, in order to save the time, I won't be free drawing this scenario again, so I don't want to mess it up. So this is the perpendicular distance, and since the line charge is positive, so in that case what we would need a unit vector which is pointing away of this point charge along this perpendicular. So there we go, the problem has been reduced to very simple one. So this distance is 4 because the coordinates were 0, 0, 4. So rho is nothing but 4, and arrow in this direction, this is the direction of z, so arrow is nothing but az. So we would write az here, since rho is equals to 4 and arrow is equals to az. So if I would like to calculate it using my calculator, so first I'll have to make it okay. So 5 nano divided by 2 divided by 5 divided by pi and divided by epsilon naught. Epsilon naught is 8.854 exponent manfi 12, okay, and also divide by 4. So we got 22.47 22.47 az is the rho is the contribution of electric field at the point of interest due to the line charge which is lying on x-axis. In a similar fashion, we would have to find, let me call it equation number 1, we'll have to find contribution of electric field intensity at this point due to line charge which is lying on y-axis. So we'll use this formula again in the numerator, since the magnitude of this line charge is also 5 nano, so 5 nano divided by 2 divided by pi divided by epsilon naught, and the perpendicular distance between the field point and the line and the line charge, which is nothing but 4 again, because we know that z-axis is perpendicular to y-axis, so it's 4 again. So in this second case, where we would need this contribution of the line charge on y-axis at this point, the perpendicular would remain the same, because we know that z-axis is mutually perpendicular to x-axis and y-axis, so the problem is not that difficult. So the direction would remain the same, because the line charge on y-axis also has got the positive value, okay, so it will push the jet charge away, so we'll have the arrow to be az. And I'm not repeating it, but in exams you'll have to give the reasons like this, okay. So now what we'll get 22.47 az is the contribution of the line charge on y-axis, contribution of field, okay. So if you would add these together using equation number 1, what we'll get electric field 22.47 az plus 22.47 az, and this will be equals to 45, approximately 45 az. And don't forget to write the units के बगैर आंसर बेमानी हो जाता है. So it is approximately 45 az volts meter. Now for part B, let's try to solve part B. For part B, the field point is given to be x0, y3, this is x0, y3, and z4. So it means that this was 004. So if I go parallel to this, if I draw a parallel here and a parallel along z-axis here, so actually this is the point of interest, okay. This is point PB, the coordinates are 0, 3 and 4. So now if I want to find the electric field intensity, if I have to find electric field intensity at point B, let me call it EB, or let me call it EA. So EA is this, okay, EA. So if I would want to find the EB, so in that case I'll have to find the contribution of electric field intensity due to rho L, which is lying on x-axis, plus electric field intensity due to rho L, which is lying on y-axis. But this time I will call it equation number 2. And one more thing, because we want to differentiate this equation and this equation, I would prefer to write A here in the superscript just to differentiate these two things, and I would prefer to write B in the superscript here, because the contribution of rho L on x-axis at point B, the contribution of electric field intensity due to rho Ly at point B. So this is how we should read it. So now the contribution of electric field intensity at point B due to rho Lx is given by this main formula. Magnitude is rho L is 5 nano 2 pi epsilon naught. Now we need rho. What is rho? Rho is perpendicular distance between the field point and the source point. So remember that. How to find it? This is our field point. We have to drop a perpendicular from here to from here on x-axis. So we are already lying on x equals to 0 plane, is it? So, and this origin is also on z equals to 0 plane. So if I would join these two lines together, these 2 points together, sorry, if I would join these 2 points together, again let me use this black marker just to emphasize that this is the perpendicular distance which we are looking for. So this is that perpendicular distance. Now this whole perpendicular line, which is perpendicular to this x-axis, sorry, so this whole line is lying on x equals to 0 plane. So something which is lying on x equals to 0 plane or x equals to constant plane will be perpendicular definitely to x-axis. This is our basic fundamental definition. Okay, so following this, now we know that the this is nothing but one side of a right angle triangle. This is the other side. This side has got the value of 3, this side has got the value of 4. So using Pythagorean theorem, we can easily find the length of this black line, which would be 5 under root 3 square plus 4 square and root. So I'm doing it without any showing any steps to you, but you would do you won't do this like this in exams. You'll have to show each and every step. So now this rho is 5, and we know that since this rho L, we are finding field at point B due to rho Lx. So this rho Lx has got a positive 5 nano Coulomb line charge density. So definitely what we are interested in is the direction which is along this perpendicular, but pointing away of the line charge. So we need something which is in this direction, a unit vector which is pointing in the direction of this black arrow now. Okay, so it's quite simple. Why? Because we know that the coordinates of the tail is 0 0 0, the coordinates of head is 0 3 and 4. So we'll do it separately. We can see that arrow is this, and we can give at an equation, and we can say that to find a row, what we need to solve this 0 minus 0 ax, 3 minus 0 ay, plus 4 minus 0 az, and under root 3 square plus 4 squared. Okay, so in other words, 3 upon 5 a y plus 4 upon 5 a z is a row. So now from equation number 3 we can say that the contribution of electric field intensity due to rho L on x-axis at point B is equals to, now we can calculate this portion, which is 5 nano divided by 2 divided by pi divided by 8.854 exponent minus 12 and divided by 5. So this is what we got, 18, approximately 18. So let me write it, 18. This came out to be 18, and a row is nothing but 3/5 ay जमा 4/5 az. Okay, so 18 into 0.6 will give me 10.8 ay, and 18 multiplied by 0.8, because 4 upon 5 is 0.8, will give me 14.4 az. Alright, so now to find the contribution of, let me separate it a little bit. So now we need contribution of electric field intensity at point B due to rho L, which is lying on y-axis. Which would be equals to rho L, which is 5 nano, divided by 2 pi epsilon naught. Now we need rho and a row again, this time rho and a row. So this is the field point, this is the line charge. So definitely the perpendicular distance which we would be interested in, if I would drop that perpendicular, so that perpendicular will be this one. Okay, because earlier the perpendicular which we got was this one. This line is, yes, definitely on x equals to 0 plane, so it is perpendicular to x-axis, but this line is actually making an angle with respect to y-axis which is not 90. That's why we adopted Pythagorean theorem. This is 90, the height was 3, this width was 4, so we used Pythagorean theorem because this was not 90. Okay, so now if I want to find perpendicular from this point with respect to this line, so I'll have to draw perpendicular such that we get 90 here. So this length is what? This length is 4. So this length is 4, and to be consistent, let me draw this with black marker so that you would recognize that this was the perpendicular distance. Okay, so again the direction will be this, and this direction is what? This direction is along the z-axis. So For the length is from here to here, it is 4, because this is 4, and the direction is what? AZ. Okay, so if you see, we have got the same problem here, the same expression here, so we don't need to recalculate that. This is what we will get. So now, using equation number 2, if we would add these two contributions, what we'll get if we add this and this, what we'll get 10.8 AY plus 45 AZ. Sorry, not 45, because AZ was 14.4 previously. 14.4 plus 22.47, it will give us 36.87 or approximately 36.9. So 36.9 AZ, this much volts meter. So this will give us the answer. So this is how we will solve this problem, and I hope you got the idea how to calculate the perpendicular distances and the arrows which was given here. Okay, I hope this helps. Assalamu alaikum.